In this video, we'll be dealing with the complex zeros of a polynomial function. Again, I will be applying some of the theorems that I talked about in an earlier video, so check that out by clicking the channel name. The video is called Properties of Polynomials, or Theorems I should say, for polynomials. Now, before I look at the first example, I want to clarify when we talk about a complex zero or a complex number, a complex number basically has the form a plus bi, where I is your imaginary unit. Okay, I is equal to the square root of -1. That's what makes it imaginary, because it's the square root of a negative number. A and B are real numbers. Now what happens if B is 0? Okay, if B is 0, this term is gone, so I'm left simply with A. But A is a real number. Okay, so keep in mind that the set of real numbers includes all the other numbers you can think of, the integers, the rational numbers, the irrational numbers, and the set of complex numbers includes everything. So basically the set of real numbers is a subset of the set of complex numbers. So I can say that every real number is a complex number, but the converse is not true. I can't say that every complex number is real. Okay, so for example, 2 is a real number, but I can put it in the form 2 plus 0 I. So it'll fit the complex form. That's why I can say every real number is a complex number. But if I have a complex number like 2 plus I, okay, can't get rid of the I there. So that's going to say complex, it's not going to be real. Okay, just so that it's clear to you. Okay, let's clear this. And let's look at the first example. Okay. This one states, find the remaining two zeros of a polynomial of degree 6 whose coefficients are real numbers and has the following zeros. Okay, so if we have degree 6, then we expect to have at most 6 distinct zeros. Okay, at most 6. Now they could be repeated zeros, so it could be, for example, something like x minus 2 to the 6th power. So the 2 is a 0, but its multiplicity is 6. It's just repeated 6 times. Okay, but if it's degree 6, I would expect at most 6 distinct zeros. Now here they give me 4 of the zeros. So they tell me 2 is a 0, -3 is a 0, 2i is a 0, and 1 minus 2i is a 0. Okay, so here's where I'm going to apply again one of the theorems from the earlier lesson. Since it has real coefficients, I'm going to use the conjugate zeros theorem that tells me that complex zeros come in pair. So that means that if I know that 2i is a 0, then it must be true that the conjugate of that, or minus 2i, would also be a 0. If I know that 1 minus 2i is a 0, then the conjugate of that, which is 1 plus 2i, would also be a 0. Okay. Now I'm going to also use the factor theorem. So let me clear this. So this is minus 2i and 1 plus 2i are also zeros. So let's clear this. So the factor theorem tells me that if k is a 0 of some polynomial f of x, and what that means is that f of k then would have to equal to 0. So the factor theorem tells me that if I know that k is a 0 of f of x, then I also know that x minus k is a factor. Okay. Since 2i is a 0, then 1 plus 2y is also a 0. Okay. So they're just asking for the other two zeros, so I'm just using the conjugate zeros theorem here that tells me if complex zeros come in pairs. So since 2y is a 0, minus 2y is a 0. Since 1 minus 2y is a 0, the conjugate of that is 1 plus 2y. Okay. Now what I just said here about the factor thing, I will be using this in the next example or so. Okay. But this one is it. That's it. Because they're just asking for the zeros. So those are the remaining two. Let's go to the next one. Okay, so here's what I'm going to use what I just said a while ago. If k is a 0 of a polynomial, then x minus k is a factor. So this one states, find a polynomial of degree 5 whose coefficients are real. So notice it says coefficients are real. So what that tells me then is that if it has any complex zeros, they have to come in pairs. So if a plus bi is a 0, then a minus bi has to be a 0, and so on. Okay, so I get the zeros of 0, minus 2i, and 1 minus 2y. Okay, so since 0 is a 0, then x minus 0 is a factor. Okay, but x minus 0 is just x. Okay, so here I want to find the polynomial. So basically I'm going to get the factors from these and then form the polynomial. So here's the first factor, x. Right here, x minus 0, but I'm just going to leave it as x minus 0 is x. Now, since negative 2i is a 0, x minus a negative 2i is also a factor. Okay, minus 2y is a 0, so x minus that is a factor. Okay, now since negative 2i is a 0, then the conjugate 2i is a 0. So 2i then has to be 2i then is a 0, so x minus 2i is a factor. So that's where I get these from. Okay, 1 minus 2i is a 0, so 1 plus 2i has to be a 0. Okay, complex zeros come in pairs. That's where I get that from. So okay, so here's where I have it then: x minus 1 minus 2y, and then x minus 1 plus 2y. Okay, that's all I'm doing. If k is a 0, then x minus k is a factor. So using the factor theorem, I form the polynomial in factored form. Okay, now this a here is just any number. Okay, basically this problem has an infinite number of solutions. You can replace the a by any number you want: negative 1, positive 1, 2, negative 2, and so on. So we just, if you want the very basic one, we use a equal to 1. But I'm just going to leave it as a for now. Okay. So this is basically the answer here. Okay, in factored form. But most instructors are going to want you to simplify this. In other words, multiply it out and write your answer without the I. Okay. So the trick here that I'm going to use, let me clear this, is this. Whenever you have, say, a plus b, parentheses, and a minus b. Okay, so in other words, whenever I multiply, I have two binomials, and I have the sum and the difference of the same two terms. I'm multiplying the sum and the difference of the same two terms. Then you should know that this is always going to be the square of the first one minus the square of the second one, right? Because if you multiply this out, that's what you're going to get. So the a times the a is going to give me the a squared. The b times the minus b will give me the minus b squared. Okay, but then here there's ab here, this product, and then there's this product over here, minus ab. So ab minus ab cancel, and I get this right here. Okay, so multiplying the sum and the difference of the same two terms is the difference of the squares of those terms. I'm going to use that basically to solve this problem. So let's clear this. Okay. So I'm going to use it right here. Okay, so we'll look at the first two terms, x plus 2y, x minus 2y. So this is a and this is b. A minus b. So the sum and the difference are the same two terms. So if I multiply that out, that'll give me the square of the first one, x squared, minus the square of the second one. So 2 squared is 4, and I squared is I squared. That's how I get that right there. Now in the second part here, all I'm going to do is here I'm going to distribute the negative. So I'll multiply through by the negative here. This becomes a minus 1, and a minus is a plus, so this becomes x minus 1 plus 2y. In the second, or the last factor here, distribute the negative. This will be x minus 1, and then here negative plus, this will be a minus 2y. Okay, so even though I have three terms, isolate these. Think of this as two terms. So think of this parenthesis right here. Think of this x minus 1. X minus 1 is one term, and the 2y as another term. This one, x minus 1, is one term, and 2y is the other one. So I have the sum and the difference of the same two terms. The terms being x minus 1 and 2y. So based on what I said, that should be the square of the first one, x minus 1 squared, minus the square of the second one. Okay, so that's how I get this second parenthesis here, to the far right here. Okay. The rest of it is just algebra. Okay, so you should know that for complex numbers or imaginary numbers, I squared is negative 1. Okay, so I replace this I squared by negative 1 here. Okay, and then here then in this parentheses I'm going to take x minus 1 quantity squared. So if I multiply, it's x minus 1 times x minus 1. Okay, so x minus 1 times x minus 1, just basically just squaring a binomial, or you can write it out, x minus 1, x minus 1. That basically gives you x squared minus 2x plus 1. Okay, so this part right here, x minus 1 squared, gives you x squared. Okay, let me write it out for you here. We'll give you x squared minus 2x plus 1. Okay, or you can write it this way, x minus 1 times x minus 1. That's what it means. X minus 1 squared is the product of this. So x times x is x squared, minus 1 times minus 1 is a plus 1. But then we go this way, minus 1 times x is minus x, minus 1 times x is minus x, minus x and minus x is minus 2x. So I get that. Okay, then over here, on this part right here, 2 squared, that's 4, and then the I squared. Okay, but then you have that minus out here. Remember, this square only applies to the 2i, not the minus, so you should have this minus. Okay, but remember, this I squared is negative 1, so negative times a negative 4 is a plus 4, so this gives me a plus 4. Okay, so then you just combine x squared minus 2x, 1 and a 4 and a 5, so that's how I get this x squared minus 2x plus 5. Okay. Now the rest of it is just multiplying through. So what I do is I multiply through by x squared. X squared times x squared is x to the 4th. X squared times a minus 2x is minus 2x to the 3rd. X squared times 5 is 5x squared. And then I multiply by the 4. 4 times x squared is 4x squared. 4 times minus 2x is minus 8x. 4 times 5 is 20. And then I just multiply through by the x. I leave the a out in front, combine my terms of course, and then I multiply by the x. And then my final answer comes out to this. Okay, so the polynomial of degree 5 that has these zeros with real coefficients is right here. X to the 5th minus 2x squared plus 9x to the 3rd minus 8x squared plus 20x times some number over here. Okay, like I said, the most basic one would be a equal to 1. Some instructors will want you to leave this as a. Some will ask you to pick a as a number, but in my classes I told them just leave the a right there. Okay, so that's the answer to this one. We'll clear it. Okay, the next one. Find the complex zeros of the polynomial function. Now remember, sometimes they're going to ask you to find the real zeros. So that means you don't give the imaginary zeros. Sometimes they'll ask you to find the rational zeros. Okay, so you only give the zeros that are rational. If it doesn't have any rational zeros, then you say no rational zeros. Now it may have irrational zeros, or it might have imaginary zeros. okay? But if it says find the complex zeros, so that means any zero, whether it's real, imaginary, rational, or irrational, and so forth. Okay, so the best way to do this is to use the rational zeros theorem. Okay, so I've worked some examples like this in the last video, so I won't spend as much time here, but basically the way it works, remember, is we take the factors of the negative 3. Factors of the negative 3 are plus or minus 1, plus or minus 3. Factors of 2 are plus or minus 1, plus or minus 2. Then I divide the factors of 2 into the factors of negative 3, and I write all the different ones that I have. So the different ones that come out are plus or minus 1, plus or minus 3, plus or minus 1 half, plus or minus 3 halves. So if this has any rational zeros, it has to be one of these. Okay, so we want all the zeros, but the best way to find all zeros is to find some rational zeros, use synthetic division, and break down your polynomial into a quadratic, where you can factor or use the quadratic formula. Okay, so what you would do then is you would plug 1 into the polynomial, negative 1, and 3, negative 3. Use the integers first before you start working with the fractions, and see if you can find a zero. So anything that makes a zero is going to be a zero of that polynomial, or you can just use synthetic division. Now I'm going to stay with the synthetic division because that's the best way to reduce it. Okay. Now if you just wanted to find them, you could just plug in, and the ones that give you zeros are rational zeros. But remember, here we want them all. So we don't want just the rational zeros, we want the imaginary zeros also. Okay, so like I did in an example in the last video, I'm going to use synthetic division. Okay, so I take the coefficients. Polynomial has to be in standard form, descending powers, and then I take the coefficients and form one row. Okay, so 2, forget about the negative 1 half here. Okay, so I start off just with this first one. So I'm going to try 3. I'm going to try 3. Okay, I tried them all, so I'm just going to give you the ones that work. Okay, but it's really a trial and error. So put the coefficients, draw your line, and then this 2 comes below the line, and you go 3 times 2 is 6. Take it over to the next column, add the numbers, negative 5 and 6, you get 1. Then 3 times 1 is 3. Take it over to the next column, negative 1 and 3 is 2. 3 times 2 is 6. Negative 5 and 6 is 1. 3 times 1 is 3. Bring it over. Negative 3 and 3 is 0. So I get the remainder to be 0, so I know that 3 does work. But remember, I said in the last video, it's possible that a particular 0 can be a repeated 0. So what you would do is you would try, or have the negative 1 half, is you would try the 3 again to see if it works. It doesn't. It doesn't. Okay, so I tried all the I tried the negative 1 and the 1 already. Okay, they didn't work. So then the next thing will be you try the 1 half for the negative 1 half. Okay, I tried the 1 half, it didn't work, so I tried negative 1 half next. So again, it's like starting over again. So it's like starting right here, the new row right here, 2, 1, 2, 1, 0. And then I put the negative 1 half, and it's just repeating the synthetic division. Bring the 2 below the line. Negative 1 half times 2 is negative 1. Bring it over to the next column. 1 and negative 1 is 0. Okay, negative 1 half times 0 is 0. 2 and 0 is 2. Negative 1 half times 2 is negative 1. 1 and negative 1 is 0. We stop right there. Okay. Now remember, I know then that 3 and negative 1 half are zeros. I can call them complex zeros, even though they don't have the I, because they are complex numbers. Okay, the complex numbers, remember, include all the real zeros, rationals, and so forth. So 3 and negative 1 half are zeros. Now, keep in mind that once you do one synthetic division, it reduces the degree of the polynomial. So we started with a 4th degree polynomial. So when I do this synthetic division, these are the coefficients right here of a 3rd degree polynomial. Now when I do the synthetic division with a negative 1 half, what's left is the coefficients for a polynomial of 2nd degree. And that polynomial would be, this is an x squared, and then it goes in descending power. So x squared, x, and constants. Okay, so this would be, what's left is 2x squared plus 0x, since it's 0 coefficient, I just leave it out, plus 2. That's what's left. So I want to know what zeros are associated with this factor right here, because that's what these are. So remember, if I wrote this out in factored form, this would be x minus 3, x minus a minus 1/2, so it would be x plus 1/2, and then this would be a third factor. So what I want to know is, when is this equal to 0? Well, since it's basic, if it had an x here and some other numbers, I would try to factor it or use a quadratic formula, but the way it's written, I would just isolate the squared term and bring the 2 over, so that's a negative 2. Divide by 2, I get x squared is equal to negative 1. And then I would just take the square root, plus or minus the square root of both sides, so it's plus or minus the square root of negative 1. But remember, the square root of negative 1, that's your I. So there it is. Okay. So the complex zeros are 3, negative 1/2, and plus or minus I. Okay. That concludes this particular video. I'll be starting with some other lessons. This actually concludes the first chapter that we cover in our college algebra course at UTB. Keep in mind that the lessons I'm giving here are abbreviated. They're a little bit longer in the actual classroom, but these videos are basically intended as a supplement to what you're learning in your classes. So I'm hoping that it'll give you some additional information and help you out in your study. So again, if you have any suggestions, please post them. And if these are helpful in some way, I'd appreciate it if you subscribe to the channel. And we'll see you in the next video.